Terrific. A very, very good afternoon to everybody. Thank you very much for joining us for yet another ECCK webinar. It's turning into a weekly event now. For those of you that are new, I'm Sven-Erik Batenburg, the Director of Legal and International Affairs here at the European Chamber. And today's webinar is about AI and ethics. Does that mean that problems are solved? Now, as an introduction, the appeal of AI has grown over the past decade. And while some see the solutions of AI to all kinds of problems, others actually raise some concern over known and unknown consequences of its often uncontrolled use. In response to the latter, ethics and AI, also known as technoethics, has been proposed as a way to prevent the occurrence of potential negative effects. The question now is, does that really quell the concerns that exist? Can you really program an intelligent machine which acts rationally and morally, while at the same time solving basic human problems? Now, our speaker for today does not have all the answers to all these questions, but he's willing to share some new aspects and thoughts to this discussion, and is also very eager to hear your concerns or your questions during this webinar. So again, for the people that might not know, we like to have our webinars be interactive. While of course there's a presentation part, there's also a Q&A part. So if at any point during the webinar you have a question that you would like to have asked and answered in the Q&A session, please type it in the chat at whenever point you feel that is relevant. And then after the presentation, we're going to do the Q&A, and then we will answer the questions, or at least ask them and see to what kind of an answer we can get. Now, as I mentioned, Robert is a professor at the University of Applied Sciences in Nordhausen, and I think this will be a very, very interesting session. I've had this one booked in my calendar for quite a while, and I look forward to a terrific session. Now with that, Robert, would you like to take the stage?
Yes, I will do. Thank you. Can you see the slides?
Very well. Thank you very much.
Okay, then thank you very much. Good afternoon to Korea and good morning from Germany. It's 8 o'clock here in the morning. I'm very happy to have the opportunity to talk to you. I want to talk about AI and ethics and whether this will solve the problems or maybe not on a broader view of the topic. I'm not the expert in all the details of AI, so I will try to match the two topics which are discussed widely, and that's the target of my presentation, to share some thoughts on that. In the beginning, I will not bother you that much with definitions, but I think we need to talk about a few to know that we are talking about the same thing. So about artificial intelligence and what does it mean. Then I will come to morals and ethics, problems to be solved, and a conclusion. And that's what we want to do today. So usually people say, okay, artificial intelligence, you can define this, but what's intelligence anyway? And usually scientists will discuss for days just to come up with no solution, most likely. So I picked one which might be suitable. And it says an entity is intelligent to the extent that it does the right thing, meaning that its actions are expected to achieve its objective. And the nice thing about this definition, it applies to both humans and machines. However, it's rather broad, but important thing, doing the right thing and achieve its objective doesn't really sound like a machine. Yeah, but so what is the objective of a machine? Is there really an objective? And what is the right thing compared to not the right thing to achieve these objectives? And this is something we will catch up with later. In general, if you would talk about artificial intelligence, you find also a lot of different definitions, and you can usually categorize them into the following four systems, which are arranged around two axes, the thinking versus acting part, and the human versus the machine part. And then on the level of thinking, you can have systems that think like humans, which are more on the human side, or you can just have systems that think rationally. Or if you go one step further, you can have systems that act like humans or systems that act rationally. And in both or in all the four areas, you have different scientists with different approaches, different research, different definitions. And then you have the big thing above all, the so-called strong AI, which is then dealing with artificial general intelligence or artificial superintelligence, meaning that the system is indistinguishable from human thinking or human acting, or even better, yeah, if it's the superintelligence. But scientists are not sure whether this can ever be reached, and because it's rather a concept than reality, and we are far away from this. Nevertheless, it can happen, but it's not the topic of today. Today, I just want to do the easy part, which is not really easy, to talk about so-called weak AI. And weak AI is something most of us probably have seen already, maybe not talking about it that way, but weak AI focuses on solving only a specific problem or one or two specific problems. For example, face recognition or playing Go or autonomous driving. And the important thing is it relies on human interference to define the parameters of its machine learning algorithms and to provide the relevant training data to ensure accuracy. To other terms, or some people would say buzzwords, which are always coming with artificial intelligence and machine learning, would be neural networks and deep learning. And they are there to increase the complexity of the problems which might be solved and also the accuracy of the solution, because they are more complex, so we can benefit more intelligence, if you want so, to an existing problem. The interesting part is that it still relies on human interference. So although we call it artificial intelligence, it's somehow reflecting also our human thinking. And it's not based only on rationality derived from mathematics, it's also derived from certain training data. If we talk about maybe immoral problem solutions, which can also be provided by weak AI, the good thing is we can now blame it not only on AI, we can also blame it on human behavior, on human thinking, on human mistakes when coming up with the problem, defining the problem or the solution. Of course, it can be blamed to the algorithm itself, but it also can be blamed on wrong training data. And what this means, I want to show you with a little example. So, for example, who's to blame for this? Headline, which was 2019 or 2020, saying Apple sexist credit card investigated by US regulators. So I was surprised that the credit card can be a sexist too, but obviously this was the claim. And it said that it was granting a higher credit limit to men compared to women. And I think this was not something Apple has intended. So is it really Apple to blame for? Or is it Goldman Sachs, which was actually running the processes behind? Or is it to blame to the algorithm itself? Did the artificial intelligence come up with something weird and all of a sudden became a sexist? Or was it the programmer of the algorithm who did something he was not supposed to? Or was it maybe the training test data used to train this algorithm, to train the system, this artificial intelligence behind? Or was it already in the beginning, the so-called data scientist and the so-called statistical model, which is used to come up with an algorithm used, for example, to run this credit card? So let's see how it could be, or how it usually should work, or how it can work. Goldman Sachs, let's say, had the problem to assign an appropriate credit limit. So somebody came up with a mathematical statistical model where you have all the parameters. Yeah? What do you need to consider when assigning a credit limit? What are the statistics? What are the correlations? derived from your historic data. How do you have to combine everything to come up with something? Certain algorithms are already there, but you have a second algorithm at the end to take then the decision, what's the appropriate credit limit to assign. And you let the system learn by using some historic data with already known results. So what you usually do is that you have these training and test data from history, and you have two groups, one for training, and then you say, okay, this person with these parameters should get this credit limit. And you give all these data into the system, so not only the input, the people who are applying for a credit limit, but also the results. And then you let the system run and to see how accurate it will come up with the results from the past. And the higher the accuracy will be, the better your algorithm will probably work. And of course, in the time in between, you will adjust your model and your algorithm. And once this has been done and you have achieved, let's say, 90% accuracy, meaning that with all the known data and all the known results, your algorithm is able to use the second group, the test data without the results. You let the system run and it creates results with a similar accuracy. So then you see that the system is obviously working in a good way. Not perfect maybe, but good enough. And once this has been achieved, you will then go and use your real data and you will come up with your future credit limits. In an ideal world, or in my ideal world, you would then have somebody interpreting the data and taking decisions manually, or at least have the chance to do so. But usually, as this is done for cost-saving reasons, pretty often you will have an automated process and it will automatically assign a certain credit limit. And then, of course, you will have some feedback into the system. So, as I said, human interference. The problem credit limit is something we came up with. For a machine, it's not really a problem. Then we came up with some models, or with one statistical model saying, okay, if you consider this and this and this and this, then most likely the credit limit should be that. This can be already a mistake by design. The algorithm or the second algorithm can also contain a mistake, but also the historic data we use. Because why would it be sexist if it's trained by pure data, by pure rationality? Nobody did anything. Of course, the historic data do reflect our behavior from the past, our actions from the past. So if in the past the system was sexist, if you want so, and you train the new system with these input, then of course your algorithm will be sexist too. So this is one of the reasons why you can blame historic data for it, if it really is sexist, because you can also say, and this would come to another problem, is it causation or is it correlation? Did the system assign, or the person before assign, a lower credit to women because of the income situation, or did it because we were women? So this is something which is one problem. The second problem comes with this situation, and it shows that such an algorithm is not necessarily something you can roll out just to other countries and to other companies. Because if you have a different social context, where certain societies where women have higher responsibility in society and also the higher income, then the whole system would fail. So it's not really intelligent in a classical way. It's only as intelligent as the system is, and the system can learn only as good as the historic data are, and the historic data always have to be seen in a certain social context. And of course, we have this classic problem of correlation versus causation. And this is something what I always don't like when I hear studies to support political purposes, or to because then everybody come up with statistics and it looks so obvious because it's based on correlation. And if you second guess this, then you may come up and say, that's not really a causation, it's just a correlation. And the more we use big data and a lot of data in defining these algorithms and these machines, the more we get caught in the trap of focusing on correlation instead of causation. And to show you how tricky this can be, there is a system from a guy called Vegan, and he came up with a lot of funny correlations, which are pretty plausible. For example, one of the correlations is the Japanese passenger car sold in the US correlates with the suicides by crashing of motor vehicle. And you see, if I would use these data, I could predict the next suicide if a car just arrived from this correlation. And that's how you train your system. Although it has nothing to do, because I don't think that Japanese cars are more suitable to commit suicide than other cars. So it's not really a correlation, but it looks like. And the system is just using data, and that's why it's tempting. You just find the right data, and then you create the artificial intelligence, which is reflecting human intelligence, just based on a wrong correlation. If you're interested in this, there's a link with 30,000 spurious correlations. So if you want to make fun of your board, then you can make a proposal to say, okay, why don't we match it with this or that? If you do so, you end up like me, so you're out of business. So you better don't. But I think it's a funny exercise to do, to see how tempting and how dangerous this can also be, to basically focus on that. So rational solutions based on data, based on facts, based on mathematics. The question is whether this is really superior then to our solutions with all its biases and errors. And if so, are those decisions considered to be favorable by humans anyway? Do we really like to have all the decisions made in our life based on rationality? And as businessmen, we should say yes, because the business theories or economic theories usually denote humans as rational agents, homo economicus. And therefore we should say yes, it's about rationality. It's business, it's not about emotions or feelings or whatnot, it's about business. Answer should be clear yes. But there are a bunch of people saying no. And what I want to do, I want to try to make a little test with you, how your real view is on this. I hope that technology is not failing on me. I prepared a little game. Some of you may know it already. It's the so-called ultimatum game, or the ultimatum bargaining game. It's very simple, not a big deal. The rules are easy. I will play with each one of you. And I'm offered $100 from my boss for each game. And I have to make you an offer about how to share it. I can say 60-40, 70-30. The only rule is that if you accept my offer, we can both keep the money according to our shares. But if you reject my offer, the money goes back to my boss. So what I want you to do is, and I hope it works, that you go to the website. You see, and now it fails. We tried it. I tried it yesterday. It's not. Give me just a second. Oh gosh. Anyway, you can go to menti.com, then we have it. Do you see my screen now, the whole screen, or just the application?
Yes. No, we see your PowerPoint presentation without full screen.
Okay, then doesn't matter. We have to improvise. I will share. This one. Oh, not really. Oh, somebody did already, right?
Yeah, because we saw already. So for everybody listening,
that's cool. So you see it. So everybody, please go to menti.com and use the code 8485917 and tell me what is the minimum amount you would accept from my offer. Yeah, would it's 50-50? Is it, would you say 40 I would accept, 30 I would accept, or 20 I would accept?
So it seems that at this point we have 6 or multitude. Oh, okay, it's increasing.
You are all businessmen. I can already see this from the results.
Well, the 50 is still 50% of people say that they want to receive 50%.
Yeah, that's cool. I mean,
$2.
I'm fine. Okay, I'll give it another 5 seconds and then I will switch back to the slide. Usually it's the technology and the artificial intelligence is supposed to help me in doing this in a presentation, but it failed on me, although I tried it just before the presentation. Okay, so keep in mind 50% accepting 50, 30 and 10. So let's go back to the slide. This is a very rational result, at least for 50% of people, because the empirical results over the years show that the majority of people offers 50-50 or 60-40 with the offer being accepted. And if the offer is 80-20, more than half of the people reject the offer. So what does it say? It means that people are not necessarily working on rationality only, because rational would be, of course, to accept $10 because it's better than nothing. Yeah? Before the webinar, you didn't have anything. Now you participated and I offer you something and you are saying me that's not good enough. I want more. Yeah? So I cannot really understand how you can really think this. Of course, I do understand, because obviously we're something more. We have a sense of fairness. We have a sense of also a bit of envious that we don't want the other person having much more for no reason. Although I was offered the money from my boss, not you, so it was just already pretty generous for me to offer something to you. So you see, rationality alone, and if we would have programmed a computer with this algorithm behind based on rationality, he would always accept the $10. But we as people would say that's not really fair. Yeah. So this should show that the results based on rationality are not necessarily accepted by people, and that there must be something more we need to add somehow into artificial intelligence if we can. Well, this sounds a bit theoretical as a game. I have another example which may show that we don't necessarily accept everything which is based on pure rationality. So I myself have programmed an AI system containing all physical and psychological characteristics of people worldwide. The problem I wanted to solve is to find the perfect match for me to live happily and laugh until death parts us. I think a lot of people are trying to find this one. And to my very surprise, it really came up with a result based on rational thought, based on all the characteristics, the parameter I entered into the system. So, and to my very surprise, it's the Hollywood actress Jennifer Aniston. And I'm pretty happy with this result, to be honest. I've been waiting for her for years. It's obviously the perfect match based on rationality. But tell me, do you think my problem is solved now? I don't think so. Even though we could say we have the perfect algorithm and we have all people, I think majority would not accept just a solution to this problem as provided by an artificial intelligence. And I'm a bit sad about that, but it's another story. So rationality alone will probably not help us. So that's already it for the AI and rationality part. Some takeaways: weak AI is more marked, designed, and strongly influenced by humans and their intelligence than it seems. Key mistakes are not only caused by wrong coding, but by wrong design of the statistical model and the algorithm, as well as by the interpretation and use of historic tests and training data. So my advice would be to invest into a data scientist with integrity, because it starts already there by coming up with a model. Some people say data scientist is the most sexiest job of our times, because you're in between working with reality, social problems, and then translate them into algorithm language if you want. So this is a key thing, because we cannot just blame it on the algorithm and the wrong programming, because you can program the algorithm only as good as the data you are using. And an AI system should not be used without knowing the social context of its origin. So just to buy an AI system and apply it to your problem in your company with your special social context, it's probably a pretty dangerous thing. And problem solutions provided by AI system, which based on purely rational thoughts, might not be considered or accepted by the people.